Hello students and good afternoon. So now I'm doing class for class 12 science. The topic is the standard integral. So in the last online class also we were doing the same topic, that is standard integral. And now today is the continuation class. So let us continue this chapter. Same exercise 6b 5 mark section from page number 363 from the book Higher Mathematics for class 12 by SND. So let's start this question number 5. So in the last online class we did question number 4. So let us evaluate this integration number 5. So you have to evaluate this integration. That is integral of root over 2x plus 1 divided by 3x plus 2 then dx. Okay. So in this case also, you have to remove square root from the numerator as we have done in the previous problem, that is in problem number 4. So remove square root from the numerator. Okay. So let us write it as first I is equal to integration of within square root, this is 2x plus 1 whole square, that is we are multiplying both numerator and the denominator by 2x plus 1 in order to remove square root from the numerator. Okay, so both these numerator and the denominators are multiplied by 2x plus 1. So it is 3x plus 2 into this is 2x plus 1, then outside square root there is dx. Okay, so or I is equal to integration of, now you can remove square root from the numerator, so it will be only 2x plus 1 dx divided by within square root. Now you can multiply these two factors, 3 2s are 6, 6x square plus this is 3x plus 4x plus this is 2 1s are 2. Or I is equal to integration of within bracket there is 2x plus 1 dx divided by within square root, it is 6x square plus 7x plus 2. Is that clear? So now what is the method in this case? So in the numerator we have 2x plus 1 and the power of x here is 1. That is known as the linear expression in x. Okay. So now in the denominator we have expression on the square root and there are terms containing x square, x and constant. Okay. So in this case you cannot separate it directly. So here is a method. The method is that you have to differentiate the expression within square root. You have to differentiate the expression within square root and write it in the numerator. Okay, त हामी यहाँ के गर्छौं, स्क्वायर रुट भित्रको जुन चाहिँ एक्सप्रेसन छ त्यसलाई हामीले डिफरेन्शिएट गरेर चाहिँ कहाँ लेख्छौं, न्यूमरेटरमा लेख्छौं. ठीक छ. So or I is equal to integration of, what is the differentiation of the term within square root? For 6x square, what is its differentiation? It is 12x, and for 7x it is 7, right? So next, now there is 12x, so here it is 2x. So you have to add constant here, not the variable. You cannot write here 12x minus 10x is 2x, but you cannot write minus 10x, that is we are adding x out there. Okay, so by which constant will you multiply this 12x in order to get 2x? That is 1 by 6. If you multiply 12x by 6, or if you divide 12x by 6, you will get 2x. Okay, so 1 by 6 into 7 is 7 by 6, but is there 7 by 6? No, there is no 7 by 6. You have to subtract it. So first you write plus 1, then write down minus 7 by 6. Is that clear? So this whole divided by within square root, it is 6x square plus 7x plus 2, then what do we write? Dx. So I hope you have understood it. So let us simplify this 1 minus 7 by 6 and then you can separate it. So or I is equal to integration of, in the numerator we have 1 by 6 within bracket 12x plus 7, right? It is 12x plus 7 plus 6 ones are 6 minus 7, minus 1 by 6. So it is minus 1 by 6, isn't it? It is 1 by 6. Then divided by, in the numerator we have within square root, it is 6x square plus 7x plus 2. 6x square plus 7x plus 2. Then what do we write? Dx. Now you can separate the term now. So let us separate the term. Or I is equal to, this is 1 upon 6 integration of, this is 12x plus 7 into dx divided by within square root, this is 6x square plus 7x plus 2. Then minus 1 by 6 is constant taken outside, integration of dx divided by root over, this is 6x square plus 7x plus 2. Is that understood now? So we have separated the term. We have separated the fraction. We have separated the fraction as well as integral sign and dx are also separated. So, or now this is I is equal, let us write it as I1 minus I2. Okay. So let, what is I1 here? 1 upon 6 integration of, this is 12x plus 7 into dx divided by, this is root under, this is 6x square plus 7x plus 2. So how will you evaluate this integration? So how will you evaluate this integration now? Okay. Now there is a quadratic expression within square root. What is that? It is 6x square plus 7x plus 2. So if you differentiate this expression within square root, you will get 12x plus 7, which is exactly in the numerator. Okay. So we can assume this 6x square plus 7x plus 2 as z square because it is on the square root and it is in the denominator. So I already told you about this method. Whenever the expression is on the square root and if the expression is in the denominator, you have to assume it as z square. So let z square is equal to 6x square plus 7x plus 2. Okay. So let us differentiate both the sides. Differentiating both the sides with respect to x. So what is the differentiation of z square? It is 2z into dz by dx is equal to, this is 12x plus 7. Okay. Or let us cross multiply it. 2z dz is equal to 12x plus 7 into dx. That is, we have got the value of the numerator. So what is 12x plus 7 into dx? It is 2z dz. Okay. So let us write it here. Therefore I1 is equal to, so I1 is equal to, this is 1 by 6 integration of, what is 12x plus 7 dx? It is 2z dz divided by, what is root over z square? It is z. So here z gets cancels, 2 ones are 2, 2 3s are 6, or I1 is equal to 1/3, this is integration of dz. So it is 1/3 integration of dz. So what is integration of dz? That is your z. So or I1 is equal to 1/3 into what is integration dz? That is your z. Then you have to write plus c. Or now this is I1 is equal to 1/3. So what is the value for z? Z square is equal to 6x square plus 7x plus 2. So z is equal to root over 6x square. So it should be root over 6x square plus 7x plus 2 plus c. Or I1 is equal to 1/3. Then within square root, actually these are the two factors. We have multiplied these two factors, isn't it? 3x plus 2 and 2x plus 1. So it is 6x square plus 7x plus 2. What are the two factors of this expression? It is, again you can write 3x plus 2 into 2x plus 1. it is 3x plus 2 into, this is 2x plus 1, then plus c. Is that clear? So we have got the value for I1. So let us find out I2. So again you have to find out the value for I2. So I2 is equal to 1 by 6 integration of dx divided by root over 6x square plus 7x plus 2. So let I2. Now let, what is I2 here? I2 is equal to this one. Let us write it. So it is 1 by 6 integration of dx divided by root over, this is your 6x square plus 7x plus 2. But the expression on the square root are the product of the two factors, isn't it? That is, what are the factors of 6x square plus 7x plus 2? This is 3x plus 2 into 2x plus 1. That means it can be factorized. Let us write down these factors. So I2 is equal to 1 upon 6 integration of dx divided by root over. So I already told you that whenever the expression is on the square root and it is in the denominator and the coefficient of x square is positive, if you can factorize the expression, factorize it. That means we have multiplied these two factors and we have written down 6x square plus 7x plus 2. That means what are the two factors of 6x square plus 7x plus 2? It is 3x plus 2 into 2x plus 1. Is that clear? Now both the factors are within square root and there is dx in the numerator. Now if both the factors are within square root and the power of x is 1, you can assume any one of the factors as z square. Okay? So let us assume any one of the factors as z square. Okay? So let us assume 2x plus 1 as z square. You may assume 3x plus 2 is equal to z square also. You may assume 3x plus 2 is equal to z square, or you may assume 2x plus 1 is equal to z square. So any one of the factors can be assumed as z square. So let us assume 2x plus 1 as z square. Okay? So let us differentiate both the sides, differentiating both the sides with respect to z. So, or it is 2 into dx by dz is, for 1 it is 0 and for z square it is 2z. So here 2 gets cancels. Now if we cross multiply, what do we get? Dx is equal to z dz. Is that clear now? So now let us put these values in I2. So therefore this is your I2 is equal to 1 upon 6 integration of, what is dx? It is z dz. Z dz divided by within square root. So we had assumed 2x plus 1 as z square. So in this case you have to put the value for x. So what is the value for x from here? So here 2x is equal to z square minus 1. Is that clear? 2x is equal to plus 1 is taken to the right hand side, so becomes minus 1. Or what is the value for x? It is z square minus 1 whole divided by 2. It is z square minus 1 whole divided by 2. So let us put the value here. Now within second bracket 3 into, what is x? Put the value for x. It is z square minus 1 upon 2 bracket closed. Is that clear? 3 into, what is the value for x here? Z square minus 1 whole divided by 2. Then you have to write down plus 2. Second bracket is closed. Then what's about 2x plus 1? It is z square. So let us put it here, z square. Is that understood now? So let us simplify it. Or now this is I2 is equal to 1 upon 6 integration of z dz divided by, what is square root of this z square? It is z taken outside. Now within square root, take the LCM. Below 2 there is 1. 2 and 1. What's the LCM? It is 2. So this numerator becomes 3z square. This is minus 3 ones are 3. Then plus, this is 2 twos are 4. 2 twos are 4. So I think you have understood it. So this z and this z will be cancelled. Is that clear? So in the next step, or I2 is equal to, now there is root 2 in the denominator, it goes up in the numerator, that is root 2 by 6. This is root 2 by 6 integration of, here z is cancels, so dz divided by within square root. Within square root, what is here? 3z square plus 1. It is 3z square plus 1. Is that clear now? It is 3z square, and this is minus 3 plus 4, which is equal to 1. So this root over 2, which is in the denominator, it goes up in the numerator. So it is root 2 by 6. Okay? Now you have to convert it into standard form again. So let us make the coefficient of z square 1. So you can take 3 common here. Or I2 is equal to root 2 by 6 integration of dz divided by within square root 3 z square plus this is your 1 upon 3. Is it clear? So let us simplify it now. Or I2 is equal to, this is root 2 by this 1 upon root 3 constant taken outside. So it is 6 root 3. Integration of, this is dz divided by root over, let us convert it into standard form. This is z square plus, what is a whole square? It is root over 3 whole square. I think you have understood it. Okay. So let us do the next step. So let us do it out here. So now this is the standard integral dx upon root over x square plus a square, which is equal to log within mod base e within mod x plus root under x square plus a square. So let us write it here. Or now this is I2 is equal to, constant term here is root 2 divided by 6 root 3. Okay, root 2 divided by 6 root 3. Then log base e within mod, what is x there? It is z plus root over, it is x plus, what is root over? Root over x square plus, what is a whole square? 1 by root 3 whole square, that is 1/3. Mod sign closed plus c. So let us put the value for z here now. Or I2 is equal to, this is root 2 divided by 6 root 3, right? This is your root 2 divided by 6 root 3 log base e within mod. What is the value for z? Z square is equal to 2x plus 1. So z is equal to root over 2x plus 1. So it is root over, this is 2x plus 1 plus root over, again what is z square here? It is 2x plus 1. So this is 2x plus 1 plus 1/3. Mod sign closed plus c. Okay. So I think you have understood it. So I think you have understood it. Okay. So next, let us simplify it further. Or I2 is equal to, this is root 2 divided by 6 root 3. This is log base e within mod root over 2x plus 1 plus root over, this is 2x plus 1 plus 1/3. This is 3 ones are 3 plus 1 is 4 by 3, mod sign closed plus c. So this is the value for only I2. So we have got both the values of I1 and this I2. Let us put these values in I in order to get the answer. So since we have I is equal to I1 minus I2, right? So here we can put the values of I1 and I2. So therefore this is I is equal to, what is I1? What was I1? I1 is that one, 1/3 root over, 1/3 root over, this is 3x plus 2 into 2x plus 1. right? 1/3 within square root 3x plus 2 into 2x plus 1. You don't have to write c. Only one c will do. Okay. Then minus what is I2? Just now we got it. It is root 2 divided by 6 root over 3. This is log base e within mod root over, this is your 2x plus 1 plus root over, this is 2x plus 4 by 3, mod sign closed, then plus c. So this is the final answer. So I think you have understood it. So this question is very, very important. This is from question number 5, isn't it? So you can copy it. So this question is very, very important. I think you have understood it. So you can copy it. So now we'll do the next question. So now we'll do the next question, that is question number 6. You have to evaluate this integral. Integration of within square root a minus x upon x dx. So in this case also you have to remove square root from the numerator. That is, you have to multiply both numerator and the denominator by a minus x. Okay. So this question number 7 is your homework, right? So here you have to evaluate this integration of 2x plus 1 dx divided by root under x square plus 4x plus 3. So here in the numerator we have 2x plus 1. Here the power of x is 1 in the numerator, that is 2x plus 1. This is the linear expression in x. And in the denominator we have both the terms containing x square and the power of x is 1 here. So this is quadratic expression. So what is the method here? You have to write down the differentiation of the expression on the square root in the numerator. त्यसमा हामी के मेथड गर्छौं, जुन चाहिँ एक्सप्रेसन अन द स्क्वायर रुट छ त्यसलाई हामी डिफरेन्सिएसन गरेर केमा लेख्छौं, न्यूमरेटरमा लेख्छौं. त्यस्तो टाइपको प्रब्लम हामीले गरिसकेका छौं. So I think you can do this at home. So this question number 7 is your homework. So now you should know the method. Okay, so let's do this question number 6 now. So therefore I is equal to integration of within square root a minus x divided by x dx. So I told you about the method for this question number 6. So both the expression are under square root and you have to remove square root from the numerator. So what is the method for eliminating square root from the numerator? You have to multiply both the numerator and the denominator by a minus x. Okay. So therefore I is equal to integration of within square root. This will be your a minus x whole square. That means we are multiplying both numerator and the denominator by a minus x. Divided by, in the denominator we have x within bracket. This is a minus x. Then what do we write? Dx. Right? So or I is equal to integration of, what is square root of a minus x whole square? This is only a minus x dx divided by within square root, here we have x into a minus x. So I think you have understood it. Okay. So now let us simplify the denominator. Let us multiply by x here. Or I is equal to integration of, this is a minus x dx divided by within square root. Let us multiply by x here. A into x, ax minus x into x. This is your x square. Okay. So now what is the method in this case? There is a minus x in the numerator. Here the power of x is 1. This is the linear expression in x. And in the denominator we have both the term containing x square as well as x to the power 1. So the expression on the square root, this is also the expression on the square root, and this is known as quadratic expression. So in this case the expression on the square root is differentiated and we write down the differentiation of this term in the numerator. त यसमा चाहिँ हामीले यसमा मेथड के गर्छौं भन्दाखेरि यो स्क्वायर रुट भित्रको जुन चाहिँ एक्सप्रेसन छ त्यसलाई हामीले डिफरेन्सिएसन गरेर चाहिँ हामीले केमा लेख्छौं न्यूमरेटरमा लेख्छौं ठीक छ सो लेट अस राइट इट हियर नाउ सो देयरफोर I is equal to integration of so what is the differentiation of the term within square root what is the differentiation of ax it is a minus what is the differentiation of x square it is 2x is that clear to all of you but we have got only minus x here so let us check for variable first so now this is minus 2x but here we have only minus x is there you have to make it only minus x by which number will you multiply it to get only minus x it must be multiplied by half okay so if you multiply it by half into minus 2x is minus x and we are getting a by 2 also is there a by 2 no first you write plus a because plus a is there first you write plus a then a by 2 is not here you have to write minus a by 2 since a by 2 is not present here so you have to write minus a by 2 so this whole divided by this is root over ax minus x square ax minus x square then what do we write dx so I think you have understood it so let us simplify a minus a by 2 or I is equal to integration of this is half this is a minus 2x and what's about plus a minus a by 2 it will be plus 2 into a 2a minus a is a by 2 so this whole divided by root over this is ax minus x square then what do we write dx I hope you have understood it okay so let us separate the term or I is equal to this is half integration of a minus 2x dx divided by within square root this is ax minus x square plus now this is a by 2 integration of this is dx divided by root over ax minus x square is that understood now so let us write it as I1 let us write this integration as I1 and this integration as I2 so or now this is I is equal to I1 plus I2 so let what is I1 out here let I1 is equal to this one half integration of a minus 2x bracket close dx divided by within square root this is ax minus x square so now in this case differentiation of the expression on the square root is a minus 2x which is in the numerator that means in this case we can use the method of substitution the expression on the square root can be taken as z square because the expression is on the square root and that is also in the denominator okay so let z square is equal to ax minus x square so let us write here differentiating both the sides with respect to x so what is the differentiation of z square with respect to x it is 2z dz by dx 2z dz by dx is equal to what is the differentiation of ax a minus for x square it is 2x now let us do cross multiplication or this is 2z dz is equal to a minus 2x bracket closed then what do we write dx that means we are getting the value of the numerator that is a minus 2x dx is equal to 2z dz so let us write these values in I1 so or now this is I1 is equal to this is half integration of what is a minus 2x dx it is 2z dz it is 2z dz whole divided by this is within square root z square root over z square. What is root over z square? It is z, right? So here 2 gets cancels and z gets cancels. So or I1 is equal to, this is integration of dz, or I1 is equal to, this is z plus c. Or what is I1 now? So I1 is equal to, what was z actually? Z square is equal to ax minus x square. So it is root over ax minus x square. Root over ax minus x square plus c. Or you may write it as I1 is equal to root over, what is common here? X within bracket a minus x plus c. So just now we got the value for I1. Okay. So let us calculate for I2. So let I2 is equal to, what is I2? I2 here is a by 2 integration of what? It is dx divided by within root ax minus x square. So this square root, in the numerator there is 1 dx divided by, in the denominator we have within square root ax minus x square. So here the terms contain x square as well as the term containing x to the power 1. So you have to convert it into perfect square form. So before that, make the coefficient of x square positive 1, because this expression contains both x square as well as x. So you have to convert into perfect square form. Before that, make the coefficient of x square positive 1. So or I2 is equal to a by 2 integration of, this is dx divided by root over, minus is taken common, so it is x square minus ax. Is that clear? Next, or I2 is equal to a by 2 integration of, this is dx divided by within square root minus within second bracket. Now x square minus ax is there. X square minus ax can be written in terms of perfect square form. That is a whole square. That is a whole square minus 2 into x into 2x is already there, but there is ax. By which number will you multiply this 2x to get ax only? Into a by 2 plus what is b whole square? A by 2 whole square. I think you have understood it. So x whole square is x square, we are getting x square, and here 2 gets cancelled, we are getting minus ax. But what is a by 2 whole square? A square by 4. But is there a square by 4? No, you have to cancel it. So you have to write minus a by 2 whole square. Is that clear? Since a by 2 whole square is not there, you have to write minus a by 2 whole square. So I think you have understood it. So let us simplify it further. Or I2 is equal to a by 2 integration of, this is dx, here second bracket is closed, on the square root. So dx divided by within square root minus within second bracket. So now this is a square minus 2ab plus b whole square. What is the formula? A minus b whole square. So this is x minus a by 2 whole square. Then you have to write minus a by 2 whole square. Here second bracket is closed. So I think you have understood it up to here. Okay. Now within square root, multiply by minus sign here. And let us write down the positive term first. Right. Or I2 is equal to, now it is a by 2 first, integration of, this is your dx divided by within square root. Now multiply by minus sign, minus into minus plus a by 2 whole square. This is your a by 2 whole square, then minus sign. So it is x minus a by 2 whole square. X minus a by 2 whole square. So it is multiplied by minus sign here. So positive term is a by 2 whole square is written first, then minus x minus a by 2 whole square. Now this is the standard integral, that is standard integral number 6th, that is the 6th standard integration, that is integral sine dx divided by root over a square minus x square. Here a is a by 2 and what is x? X minus a by 2. Okay, so what is the formula in this case? Or I2 is equal to, this is a by 2, what is the formula? It is sine inverse x by a. Here x is x minus a by 2 divided, what is a? A by 2, bracket close, plus c. Okay, now simplify it. Or I2 is equal to, what is here? Or I2 is equal to, this is a by 2, this is your sine inverse within bracket. What's the LCM in the numerator? 2. And this 2 and this 2 will be cancelled after taking the LCM. Okay, so it is 2x minus a, 2x minus a divided by, this is a, bracket closed, plus c. So we have got the value for I2. Is that clear to all of you? So let us put these values of I1, these values of I1 and I2 in this I. So here since I is equal to I1 plus I2, or this is I is equal to, what is I1? What was I1 actually? It is root under x into a minus x. It is root under x into a minus x. There is plus c. You don't have to write plus c. Last man c लेखन भाई also you c बुझ्यो plus what is I2? It is a by 2. This is sine inverse within bracket 2x minus a divided by a, bracket closed. Then we can write plus c. So this is the final answer. So I think you have understood it. So you can copy it, and that question number 7 you can do it at home. So that question number 7 is your homework. Okay, so now we'll do next question. So now we will do some methods of integration now. So there are two methods for integrating an integration of the form, that is, so let us write here integration of the form, So let us write down the method for integration of the form. That is, first one is integral sine dx divided by, this is ax plus b, this is your ax plus b, right? This is your ax plus b into ax plus b into, within square root we have px plus q. So now in this case, you have to evaluate this integration of this type, that is dx divided by ax plus b into root over px plus q. Now in this case, outside square root there is ax plus b, and here the power of x is 1. This is the linear expression in x. And within square root also there is expression px plus q. Here within square root also, what is the power of x? That is also 1. That is also linear expression in x. So both these expressions are linear expression in x. One is under square root and one is outside square root, but both are in the denominator, and in the numerator we have only dx. So if you have such type of integration, what is the method for integrating it? So method for integrating it is, you always put the expression on the square root as z square. Okay, that is z square is equal to px plus q. So whenever you have such type of expression, then we always assume the expression on the square root as z square. That is, you put z square is equal to px plus q. Suppose integration is the type of integration, that is integration of dx divided by ax plus b into root over px plus q. So here ax plus b is there. It is not on the square root, it is outside square root. Here the power of x is 1, that is the linear expression in x, and the other expression is under square root, that is px plus q, where the power of x is also 1 here. This is also the linear expression in x. So what is the method for integrating it? So always you have to assume the expression under square root as z square in this case. So let us put z square is equal to px plus q. So that is the method. Is that clear? Tara यो दुईटामै x को पावर चाहिँ के हुनुपर्छ 1 हुनुपर्छ, लिनियर एक्सप्रेसन x हुनुपर्छ, then only we can assume this z square is equal to px plus q. So this is the first method. Okay, now the second one. So you may have the question like this also, integration of the form dx divided by, so it is px plus q outside square root, and within square root you may have the quadratic expression in x, that is ax square plus bx plus c. So whenever you have such type of integration, that is integral sign dx divided by, in the denominator outside square root there is px plus q, and within square root there is ax square plus bx plus c. So whenever you have such type of integration, so how can you do it? How can you evaluate this integration? So there is a method. So here outside square root this is px plus q, here the power of x is 1, and within square root the highest power of x is 2, that is the quadratic expression in x, and there is term containing x also within square root. So in this case the method is you put px plus q is equal to 1 upon z. So here in this case a, b, p and q are constant, and in this case p, q, a, b and c are constant. Okay, so whenever you have such type of integration, so what is the method for integrating it? You always put px plus q is equal to 1 upon z. So the expression outside square root is the linear expression in x, and the expression under square root is the quadratic expression in x. So whenever you have such type of expression, we always put px plus q, that is linear expression, as 1 upon z. So these are the two methods that you should remember. Okay, so now we will evaluate this type of integration now. Okay, so let us do it. So let us write down the question now. So the question is, so it is so number 8 will be your homework. So I am writing the question number 8. So this is your homework. That is question number 8 is integral sign dx divided by, in the denominator we have, so x plus 2 into root over x plus 3. So it is integral sign dx divided by x plus 2, and within square root we have x plus 3. So this is your homework. So question number 9, there is similar type of question, that is question number 9. We will do it here. Okay, so question number 9 is integral sign, that is dx divided by, in the denominator we have, it is 2x plus 3, 2x plus 3, and within square root we have x plus 5. So question number 8 and question number 9 are of similar type of problem, and we can use the same method in this case. Okay, so question number 8 is your homework. Now we will do question number 9. Okay, so just now I told you about the two methods of integration. Okay, so for this question number 8 and question number 9, which method is used? Will you use first method or second method? First method was assuming the expression under square root as z square, and the second method was assuming the expression outside square root as 1 upon z. So this is the first method, because in this case 2x plus 3 is outside square root, here the power of x is 1, and within square root also the power of x is 1. Both are linear expression in x. So you have to assume the expression under square root as z square. So similar is the method for question number 8. So question number 8 and question number 9 are of similar type. So let's do this question number 9. So I is equal to integration of dx divided by 2x plus 3, then root over, this is x plus 5. So we can use the first method in this case. Just now I explained you about two methods of integration, that is first method and the second method. So now in this case the first method is used. So what is the first method in this case? The expression on the square root can be assumed as z square, because the power of x for both the expression here is 1. That is 2x plus 3, x to power 1 say here, x plus 5, here also the power of x is 1. So the expression on the square root can be assumed as z square if you have such type of integration. So let z square is equal to x plus 5. So differentiating both the sides, with respect to x. So what is the differentiation of z square? It is 2z dz by dx is equal to 1. Differentiation of x with respect to x is 1. For 5 it is 0. So let us cross multiply. 2z dz is equal to what? It is dx. Okay. And from here you have to get the value for x also. So what is the value for x here? X is equal to z square minus 5. Okay. So let us put these values in I. So therefore I is equal to integration of, this is dx. What is the value for dx? It is 2z dz divided by, now within second bracket, 2 into what is x? Here you can put the value for x. What is x? It is z square minus 5, bracket closed. Then you have to write down plus 3, second bracket is closed. And this is on the square root. What is x plus 5? It is z square. So what is root over z square? It is z. So here z will be cancelled. Understood? So now, or let us simplify it. I is equal to, which constant is taken outside here? 2 is constant, it is taken outside. So it is 2 integral sine dz divided by, now multiply by 2 here. It is 2z square minus 2 5s are 10 and then plus 3. Plus 3 is there. Okay. So let us simplify it. Or I is equal to 2 integration of dz divided by 2z square minus 7. So it is z square and only 7 is there. You have to convert into standard form. Let us make the coefficient of z square 1 by taking 2 common. So in order to convert it into standard integral, always make the coefficient of x square or z square 1. Okay. So or now this is I is equal to 2 integral sine dz divided by, here 2 is taken common. So it is z square minus 7 by 2. So here 2 gets cancels. So or I is equal to integration of dz divided by z square minus, let us convert it into whole square form. That is root 7 by root 2 whole square. Is that clear? So which standard form is this one? It is standard form number 2. That is integration of dx divided by x square minus a square, isn't it? So which is equal to 1 by 2a log within mod x minus a upon x plus a, mod sign close, the base is e, then what? Plus c. So here x is z and a is root 7 by root 2, right? So or I is equal to, what is the formula? 1 by 2 into what is a? Root 7 by root 2, that is 1 by 2a log within mod. Here the base is e. X minus a. What is x minus a? Z minus root 7 by root 2 divided by, what is x plus a? Z plus root 7 by root 2. Mod sign closed plus c. Understood? So now here you can cancel root 2 ones are root 2. Root 2 le 2 like what the times? Root 2 times. Okay. So or what is I? So I is equal to, this is 1 by root over 14. You can multiply root 2 by root 7. It is root 14. Then log base e within mod. In the numerator and in the denominator, you can take the LCM. What is the LCM? Root 2 root 2. both of these root 2 after getting the LCM will be cancelled. So this is root 2 into z minus root 7 divided by, in the denominator, root 2 into z plus root 7 mod sign closed plus c. So let us put the value for z. What is z actually there? Here we had assumed z square is equal to x plus 5. So what is the value for z? It is root under x plus 5. So or I is equal to, this is 1 by root over 14. This is log base c within mod root 2 into, what is z actually? It is root over x plus 5, because z square is equal to x plus 5. What is the value for z? It is root over x plus 5. It is root over x plus 5 minus root 7 whole divided by, similarly in the denominator we have root 2 into root over x plus 5 plus root 7 mod sign closed. Here the base is e and then plus c. So this is the final answer. So I think you have understood it. So you can copy this question number 9. So question number 8, similarly you can do it. So that is your homework. Okay. So let's do next question now. So now we'll do the next question, that is question number 10. So question number 10 is integral of dx divided by within square root 2 upon 3 x cube minus x square plus 1/3. So which method is used in this case? Whether it is first method or second method, we don't know, because this is cube. X cube is also there, x square is also there. So let us simplify it first. Okay. So let us write here I is equal to integration of, this is dx divided by within square root, what's the LCM? So here the LCM is 3. So the numerator here will be 2x cube minus 3x square plus 1. Okay. So here this is root 3, which is below the denominator. So after simplification it goes up in the numerator. So this is also constant. So you can write it before integration sign. That is root 3 integration of, this is dx divided by, this is root over 2x cube minus 3x square plus 1. Okay. Now you have to factorize the expression on the square root, because this is cube. The expression is of cube expression. So you can factorize this expression. Okay. So let us write down the expression on the square root here. That is 2x cube minus 3x square plus 1. It is 2x cube minus 3x square plus 1. So in this case you can do the middle term breaking. So if you multiply two numbers you should get 2, and after adding, because before 1 there is plus, so after adding those two numbers you should get 3. So that is 2 ones are 2 and 2 plus 1 is 3. So you can break the middle term here. So it is 2x cube minus within bracket 2 plus 1 into x square plus 1, which is equal to 2x cube minus 2x square minus plus minus x square plus 1. So what is common out here? What is common out here? The common here is 2x square. 2x square is common, so it is x minus 1. Here minus 1 is common, so it is x square minus 1. Okay. So x square minus 1 also can be factorized. So it is 2x square into x minus 1 minus. So what is x square minus 1? We can use the formula of a square minus b square, which is a plus b into a minus b. So it is x plus 1 into x minus 1, right? So again, what is common? X minus 1 is common. So within bracket, what do we get? It is 2x squared. This is minus x minus into plus minus 1. This x minus 1 is already taken common out here. So it is 2x squared minus x minus into plus minus 1. So here bracket is closed. Okay. So now again you can factorize that 2x square minus x minus 1 by middle term breaking here. So if you multiply the two numbers, you should get 2, and after subtracting, here the coefficient of x is 1, you should get 1. That is 2 ones are 2 and 2 minus 1 is 1. Okay, so which is equal to x minus 1 within second bracket, it is 2x square minus within bracket, instead of here the coefficient of x is 1, so instead of 1 you should write 2 minus 1, and this is minus 1, second bracket is closed. So which is equal to, this is x minus 1 within bracket 2x square, sorry, this is coefficient of x is 1, so it is 2 minus 1 into x minus 1. Okay, second bracket is closed, you have to write down x there. So you should multiply now. So it is minus 2x, minus to minus plus x, then minus 1. Okay, so which is equal to, this is x minus 1 within second bracket. What is common here? It is 2x common, so x minus 1 plus 1 common, so it is x minus 1, second bracket is closed. Okay, so which is equal to, this is x minus 1, again what is common here? This is x minus 1 into, this is 2x plus 1. Because here x minus 1 is common, it is taken outside, and the remaining terms are kept within bracket, that is 2x plus 1. Okay, so what is x minus 1 whole square? What is x minus 1 into x minus 1? It is x minus 1 whole square. X minus 1 into x minus 1 is x minus 1 whole square. Into, you have to write here, this is 2x plus 1. Okay, so let us put it out here. Or I is equal to, this is root 3 integration of dx divided by within square root. What is this factorization? It is x minus 1 whole square into 2x plus 1. Is that clear? So within square root, x minus 1 whole square can be simplified. It can be taken outside. So or I is equal to, this is root 3 integration of dx divided by, this is your x minus 1, then within square root, this is 2x plus 1. Now here in this case we can use the first method. Both are in the denominator. Here the power of x is 1, x minus 1 is outside the square root, the power of x is 1, that is linear expression in x, and under square root there is 2x plus 1. Here also the power of x is 1, that is also the linear expression in x. So we can use the first method in this case. So the expression on the square root can be taken as z square. So let z square is equal to 2x plus 1. Now the expression on the square root, the expression on the square root is 2x plus 1. We can take it as z square. Okay, so let us differentiate both the sides with respect to x. So differentiating both the sides, with respect to x. So what is the differentiation of z square? It is 2z dz by dx is equal to, for 2x it is 2. From both the sides you can cancel this 2, or z dz is equal to what? It is dx. So cross multiplied, so z dz is equal to dx. Okay, so now from here you can get the value for x also. That is 2x is equal to z square minus 1, and what is x is equal to? Z square minus 1 whole divided by 2. Okay, so let us put it here in I. So I is equal to, which is constant here? It is root 3 integration of, what is dx? It is z dz divided by, here we have within bracket, what is the value for x? Here x is z square minus 1 by 2, then minus 1 is there, right? Minus 1, bracket closed, and within root 2x plus 1 is z square. So what is root over z square? That is z. So here z gets cancels. So or I is equal to, this is root 3 integration of dz divided by, what's the LCM here now? This is 2. So here we have z square minus 1, minus 2 ones are 2. So now this 2 goes up in the numerator after simplification. So that 2 is constant, taken outside. So I is equal to, this is your 2 root 3 integral sine, this is dz divided by z square minus 3. Minus 1 minus 2 is minus 3, isn't it? So here you can convert it in standard form now. So I is equal to 2 root over 3 integration of dz divided by, this is z square minus, here what is a whole square? It is root over 3 whole square. So this is the standard form, integration of dx divided by x square minus a square. Instead of x there is z, instead of a there is root 3. So what is the formula that you can use here? Or I is equal to, this constant is already there, you have to write it, 2 root 3 into, so what is the formula for this standard integration? What is integration of dx divided by x square minus a square? So it is 1 upon 2a log within mod x minus a upon x plus a. Okay, so it is 1 upon 2 into, what is a here? Root 3. Then log, the base is e within mod. What is x minus a? It is x means z minus a means root 3 divided by x plus a. What is x plus a? It is z plus root 3, mod sign closed, plus c. Okay. So here 2 root 3 gets cancels. So this is 1, you don't have to write it. Or I is equal to log base e within mod. What is the value for z? What is the value for z in this case? What is the value for z? It is z square is equal to 2x plus 1. What is the value for z? It is root over 2x plus 1. It is root over 2x plus 1 minus root 3 divided by, again what is z? It is 2x plus 1 plus root 3, mod sign closed, plus c. So this is the final answer. So I think you have understood it. So you revise all the problems that we did today. Do the homework also. Okay. If you don't understand anything, you can call me, you can ask me, or you can write down the comments. Okay. And in the next online class, we will do more problems on this standard integral. And you have to do, and we have to do that method number 2 also. So in the next online class, we will do all these type of problems. Okay. So this much is for today.